Welcome all, Richie here. It is day 13 of our 14 concepts. So we are getting very, very close. Obviously, you do not want at this stage to be ramming into your head complex concepts that have floored you so far for the last 6, 7, 8, 9 months, because it'll probably just derail your studies. So you're just trying to clean things up at the minute and maybe look at analyzing, interpreting things that have caused you problems in the past, just to take out what you can from them. As an example, let's look at two things. First of all, the confidence interval for a prediction in a regression, and something that a lot of people have just completely sidestepped when they've studied level 1, which is the standard error of the forecast. So here we go. Some basic data. We've got the output from a regression here. So we have our intercept and our x variable 1, meaning b0, b1. This is just Excel's version of it. And what we're going to do is make a prediction using an independent variable value of 12. So x is going to be 12. And we're going to predict y. Now, I'm saying in the exam, you absolutely have to be all over that. That I would dub a gift, an absolute gift. It's 27.81. That is our prediction of y. But I'm asking you here for a 95% confidence interval. You should, from previous readings, be all over confidence intervals. Critical t-value, 95% we were asked for. n-2 is your degrees of freedom in a regression, comes from here. n-2 and 95%. Your critical t will be 2.306. I don't think they're going to make you look that up. It doesn't really achieve too much. So let's assume we just know that critical value. This is the killer. The standard error of the forecast. Let's assume for the moment, and I know it's a big cop-out, but let's assume that's given. In which case, our interval is pretty straightforward. It's going to be our estimated value of y plus or minus our critical value, as a confidence interval always is, multiplied by the standard error of the forecast. That will give you your interval. Now, if you do the math, you will get a lower end of 25.7. Our estimate of y will be within that, and an upper value of 35.05. So I think you should be able to do that, given the standard error of the forecast. So the point I'm making is you get to the end of regression, you think, oh, all those big formulas about SF and SE, it's just a nightmare. Pick out what you can. Assuming, and I know it's an assumption, but assuming they give you the standard error of the forecast, getting the confidence interval for a prediction is just like a confidence interval of anything else. You take your point estimate, which is an absolute gift. You take your critical value, which you just need to look up in a table, probably given to you. And okay, you need SF, which is a beast of a formula. But if it's given to you, my point is you don't want to have overlooked this whole thing just because the SF formula is a nightmare. Imagine they give it to you on the day. You can do it easily. You can come up with that. Now, that said, okay, here is the SF formula, and I admit it's a bit nasty. And going back to what I opened this video with, you do not want at this stage to be dedicating the 26, 28, 30, 34, whatever hours you've got left till the exam trying to swallow this formula if you haven't so far. Now, I've given you the numbers. These are the relevant numbers. If you shoved all of those numbers in, believe me, that would come out to 2 decimal places to 3.14. You don't want to watch a video of me just sticking numbers in here. But what I'm going to say is this: don't just write it off. Analyze. Go to the curriculum and say, okay, what do they say about the standard error of the forecast? Yes, they give me the formula. Yes, they vomit some numbers in and it vomits out 3.14. But the majority of the curriculum, or majority of the page that talks about SF in the curriculum, is interpreting and getting you to talk about it. And those things you can now just stick into your mind. Look at the formula. Don't say to your brain, you need to swallow this formula and remember it. Say to your brain, well, what can we say about this formula? It starts off with the standard error of the estimate. Now, the standard error of the estimate, I think, is worth knowing. I think it's calculatable and worth knowing. It is just the square root of your mean squared error. It's just the square root even of 6.11 from your ANOVA table. What does that give you? 2.4718. So that bit is okay. Can I interpret that standard error? Well, you know what the term standard error means. We've seen it in a sampling distribution. And if you go back to the ANOVA table, what is this? This comes from the sum of squares residual. So this is a function of how far away each observation is from your regression line. It's these distances. So if you think about it, the further away your observations are from the line, the larger this is going to be, the larger this is going to be, the larger that's going to be, and hence the wider your prediction interval. That makes sense. Your prediction interval won't be as tight. It'll have to be wider if your regression isn't as good because your residuals are larger. Your brain will be able to remember that because it makes sense. Now the second term, which is, truly the beastie bit. Well, it's in here, 1. Okay, 1. 1 over n. N is obviously my sample size, how many observations I had. Now, what happens? It's there and it's there. What happens as n gets larger? Well, this term is going to shrink. This is in the denominator, so this term will shrink. So as n gets larger, SF again will get smaller, meaning a tighter confidence interval. So we know if our sum of squared residuals, and hence the standard error of the estimate, reduces, this comes down, this comes down. That makes sense because these are all tighter to my line. We know that if we have a larger sample size, this denominator is larger, this term gets very small, this comes down. That makes sense to me too. The more data I have, the tighter my prediction interval can be. And finally, let's look at the value of X we used to make a prediction. Here we used 12. The mean was 5.5. This is in the numerator. The bigger that distance is, the bigger the standard error of the forecast will be. So conversely, if we can bring that numerator down, then we can bring the standard error of the forecast down and the prediction interval will be tighter. How do I get this term to be small? Well, I want a value of X that is close to the mean. The closer my prediction value, that's the right term, the independent variable I'm using to predict, the closer it is to its mean, the smaller the standard error of the forecast. That makes sense because you're in the middle of the data. As you move out to the extremes of the data, you're doing more extrapolation. The model is more confident towards the middle. So I haven't told my brain we have to remember all of this, but I've gone through a little exercise for 5 minutes where I tell my brain, look, can you just remember these things? As the sample size goes up, standard error of the forecast comes down, tighter interval, that makes sense. As I get closer to the mean of X, closer to the center of the data, in terms of the independent variable, standard error of the forecast comes down, smaller prediction interval, makes sense. And if I can get the standard error down by having smaller residuals, it's a better model, my prediction interval is tighter. Okay, your brain has a good chance of going away happy with that and saying, yeah, that makes sense. That's some good analysis and it's logical. So if you see a big formula towards the end of your studies now, you're trying to mop things up, don't dive in and start to try and learn every aspect of it and just waste time doing big calculations. If I was the examiner, I'm not going to make you sit and calculate that in 90 seconds. It's just a waste of everybody's time. But absolutely, I'd want to know that you knew how I can get a tighter prediction interval with my model. Well, quite simply, have a better model, have a larger sample size, and make predictions closer to the mean. That's the way to think about it. And it's much more fun to start mopping up things like that rather than stressing yourself out learning formulas. 1 day to go.